Okay, so obviously we've been teaching you all of this stuff about square roots for a reason. And that's because from now on you'll be asked to do a lot of things in exact form. Okay, we have done this a little bit already this year, but starting now and heading into year 4, a lot of your work will require an exact answer instead of one that's been rounded. Okay, now an example of where we use this a lot is with right angled triangles. So let's try drawing a right angled triangle, and we will calculate the length of one of its sides in exact form. Okay, so this is a right angled triangle. We will say that this side is going to be, doesn't really matter, root 5. Okay, we will say that this side over here is going to be 3 root 7, and we want to know the third side. Okay, so let's say we're going to find this out. Now, you guys know, or I assume that you know, this is something we do expect that you know by now, Pythagoras' theorem. Again, Pythagoras' theorem is a squared plus b squared equals c squared. Okay, now we will label this triangle A, B, C, okay, because we actually need to make sure we use the right labels for our sides when we're doing this. Okay, now we will call side A AB, so AB squared in this triangle, plus our other shorter side is this one here. This is the CB side, so we'll make this CB squared is equal to, and I should use this properly, let's make it BC, because we always write them alphabetically, is equal to AC squared. Okay, so this is our Pythagoras rule for this specific triangle. And guys, it's really important that you write these things out first. Okay, now AB squared is x squared. Okay, lovely, nice and easy. Plus BC squared. So we have the square root of 5 squared. And if you forget how to do this stuff, you might want to go back and watch some of the videos from year 2. Okay, and that is equal to AC squared. So 3 root 7 squared. Okay, so let's simplify this. We have x squared plus the root of 5 squared. If we square a root, we just get whatever's under the root. So we have here 5 is equal to. Now here, when you apply the square, you have to also apply it to the 3 and not just to the root 7. Okay, so we get 3 squared. So we get 9 times root 7 squared, which is 7. Okay, so x squared plus 5 is equal to 63. Okay, we're going to minus 5 from both sides to get x by itself. So now we have x is equal to 63 minus 5, which is 58. X squared, sorry, is equal to 58. Now, to get x by itself, we have to take the square root of both sides. So we have the square root of 58. This is not a square number, okay? So it's not something that we can take the square root of. That means it's irrational, okay? So the square root of 58 is an irrational number. Now, with irrational numbers, as we said, those decimals after the decimal point go on forever, which means that we can't actually write them in a clear way, okay? What we have here, x is the square root of 58. That is exact. That's as precise as we can get this. So we want to keep it in that form for that reason, so that we have an exact answer. Now, one reason that we do this is because if you want to use this answer further on for more parts of your question, it's important that your answer was exact, otherwise you're going to change your answers further on. Okay, if you start rounding during a question, you end up with mistakes later on. Okay, so we really want you to get in the habit of answering things in exact form. So we have found x. If I said to you, I wanted to know what the perimeter of this triangle is, okay, the perimeter of this triangle is equal to all the sides added together. So it's AB plus BC plus AC. Okay, so in this case we have AB, which was the square root of 58, and we can't simplify that one, plus BC, which is the square root of 5, plus AC, which is 3 times the square root of 7. Alright, and as you saw from the last 2 lessons, these are not like terms. The square root of 58 is as simple as it gets. We can't change it. The square root of 5 is also as simple as it gets, and 3 root 7 is also already simplified. So this would be our final answer in this case, and this is in exact form. So this is what we want to see from now on when you're asked to do something exact. Okay, this also counts for other situations. Okay, at any point when we ask you something, we really would like to see things left as fractions or as square roots as much as possible, unless we otherwise tell you that we want it rounded. So please leave it like this. The only other calculation that we can do here is we could also find the area of the triangle, and we know that the area of a triangle is half times the base, and our base here is AB, times the height, and in this case our height is BC. Remember, the height and the base are perpendicular to each other, so there's a 90-degree angle between them. So we have in this case a half times AB, which is root 58, times BC, which is root 5. Okay, now in order to work this one out, and again we want it exact, we're going to do half times 58 times root 5. So let's do 58 times 5. Okay, because we know our rule here, we have the square root of A times the square root of B is equal to the square root of AB. So we can just multiply those together. So from what we had here on the calculator, 58 times 5 is 290. So it's half times the square root of 290. Okay, we should think about whether 290 can be divided by any of the square numbers to see if we can simplify it. And in this case, actually it can't. So we're just going to have as our answer half the square root of 290. And that is our exact answer for the area of this triangle. Okay, so this is the kind of thing we want you guys to be able to do.